Alright, in this video we are going to take a look at calculating specific heat. Specific heat is basically a quantity that means how much heat a substance can absorb or lose without changing temperature. So things that have a high specific heat, you may hear it called heat capacity. Heat capacity and specific heat are basically the same thing. So for something that has a high specific heat or a high heat capacity, means that it can absorb a lot of energy before its temperature increases very appreciably or very much, and conversely it can lose a good amount of heat energy before the temperature decreases. Something that's got a good amount of specific heat or a high heat capacity is water. So the units you may see for specific heat, there are a couple of different ones you may see. You may see one called joules per grams time degrees Celsius. So joules, the J stands for joules. So J, we'll say, is joules, and joule, it's not joules, it's J-O-U. That doesn't really look like too much of a U, but it's J-O-U-L-E. So it's not pronounced joule. I have heard that, but that is incorrect. It is joule. It's joules per gram. The G stands for gram, and the C is degrees Celsius. So degree is Celsius. You also may see, instead of C, you may see K. So K is a unit of measurement that means Kelvin. Now, Kelvin and Celsius, um, they're similar in the fact that, let's say if I have a thermometer, and I've got a thermometer, let's say my first thermometer measures unit of Kelvin, and let's say my second thermometer measures Celsius, and let's say I'm going from 0 to 1 and 0 to 1. Alright, so let's just pretend that this is a teeny tiny little portion of a thermometer. So here's maybe my bulb on the end or whatnot. But anyhow, so here's a little portion of a thermometer here. So even though these are not exactly the same, meaning that 30 degrees Kelvin is not the same thing as 30 degrees Celsius. These are not equal. So 30 degrees Kelvin does not equal 30 degrees Celsius. But even though these aren't equal, if I increase by 1, so if I go from 0 to 1 on the Kelvin scale, or if I go from 0 to 1 on the Celsius scale, that is the same amount. So even though 30 degrees Kelvin and 30 degrees Celsius are not the same, if I went from 30 to, say, 31 degrees Kelvin, that is the same difference as 30 degrees Celsius is to 31 degrees Celsius. So the actual degree themselves, they're equivalent. But like I said, don't get this mixed up in thinking that Celsius and Kelvin are the same numerically, because they're not. Because like I said, 30 degrees Kelvin is not equal to 30 degrees Celsius. But the distance that I have to move from 30 to 31, or the amount of, I guess, average kinetic energy to go from 30 to 31 on the Kelvin scale is exactly the same as to go from 30 Celsius to 31 Celsius. And maybe this is, a little too much detail for that. But anyhow, you may see Kelvin in place of Celsius sometimes. So if you see joules per grams times K, and normally you don't put the little degrees symbol on the K, it's just the K. Basically, the C and the K, these two units would be equivalent, so you wouldn't really have to do anything different for these. However, another unit that you may see is calories per joule. No, not calories per joule. Let's get rid of this. Let's do, where's my eraser? So let's get rid of the joule there. But what you may see is calories per gram times degrees Celsius. So here the CAL stands for something called a calorie. A calorie is a unit of measurement of heat energy that we use in the United States, whereas a joule is a unit of heat energy, but this is the metric system. This is the SI unit. So this is typically the one that you're going to see in a science class. But anyhow, in a nutshell, that's what specific heat is. And in calculating specific heat, the formula that we're going to use for that is Q is equal to MC delta T. So here's our formula for calculating specific heat, or calculating heat energy specific heat. So let's scroll down to the actual problem, and I will explain what the Q's and M's and C's and everything mean. So before we actually do this problem, let's do this again. So I'm going to rewrite the formula. So I'm going to say Q is equal to MC delta T. So this is a triangle, which means delta. So Q is basically, it means our energy. And like we said before, energy can come usually in two different units that you're going to see. One, you're going to see the unit of joule, and the other one that you may see is the unit of calorie. Well, you may ask, well, how do I know which one to use? And basically what you do is you look at your specific heat, but we'll see that in just a second. So if we move to the M stands for mass, and mass is going to be measured in grams. So the delta, if you'll recall, delta T, delta means change in. It means the difference. So delta T basically is this. So here's a formula for your delta T. We're going to say TF, which is going to be T final, so I'm going to write final out here, minus T initial. Now, initial means what you actually start with, or it means your conditions at the beginning. So delta T is your change in temperature, where T, we'll write temperature out here. I'll put this in parentheses. So T stood for temperature. So delta T is your change in temperature. So your final temperature minus your initial temperature. And C is your specific heat. Now, why they chose C to be specific heat, I'm not sure. Maybe because of the C here, or maybe it's just completely arbitrary. But anyhow, C stands for, or C represents your specific heat, and the units we're looking for is joules per gram times degrees Celsius, or we're going to say calories, C-A-L, calories per gram times degrees Celsius. Alright, so let's go back up to here. So we were thinking, well, do we use joules or do we use calories? Well, it all depends upon your unit of specific heat. So if we take a quick look at the formula here, we just read da 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 da, and it says if the specific heat of water is this guy. So the specific heat of water is 4.18 joules per gram times degrees Celsius. So this is the unit of specific heat that we're using, joules divided by grams times degrees Celsius. So what that means is that the unit that we are going to use for energy is the joule, because they always have to be consistent. If I use joules here, I have to use the J for my specific heat here. However, if my unit for specific heat up here had said calories, then I would have used this unit for my heat. But because it didn't say calorie, it said joules, we are not going to use the calories for this particular example. So let's go ahead and scroll down, and let's actually solve this problem. So let's write out our specific heat again, our formula. So Q is equal to MC times delta T. So let's read the problem. I probably should have written a little smaller so I didn't have to scroll as much, but anyhow. So it says 100 milliliters of 4 degrees Celsius water is heated until the temperature is 37 degrees Celsius. If the specific heat of water is 4.18 joules per gram degree Celsius, calculate the amount of heat energy needed to cause this rise in temperature. So what I'm going to do, I'm going to take a different color, and I'm going to write out my variables to the right, and we're going to go ahead and put in what they are. So I know I'm looking for Q. Q is actually what I'm looking for, so I don't know what Q is, so I'm going to put a question mark here. The next variable in my formula is mass, so M is equal to the mass of the water. Let's see, well, they give me volume, they don't give me mass. So here is a conversion factor that will be useful to know. 1 milliliter of water, of H2O, is equal to 1 gram of H2O. So when you're talking about water, milliliters and grams are interchangeable. They're basically, it's a 1-to-1 ratio. So whatever you have for milliliters, you can have for grams. So instead of 100 milliliters, we can go ahead and put 100 grams for the mass of our water. Well, the next thing that we're going to look for is C, and the C is a constant. They give it to us, and it is right here. Well, let's include the unit on it also. So it's 4.118 joules per gram times degrees Celsius, And the next thing we have to do is delta T. So remember we said delta T is our final minus our initial. Well, the final temperature, what I end up with, let's see, is 37 degrees Celsius. That's how hot that I'm making it to. So that's what I'm ending up with. But what did I start with? I started with 100 milliliters of 4 degrees Celsius water. So I started with 4. So if we take 37 minus 4, 37 degrees minus 4 degrees, our delta T is equal to 37 minus 4 is 33 degrees Celsius. So that is our delta T. So now let's just take these and plug them into our formula. So let's scroll down just a little bit here so we can see what's going on. Okay, so I know I'm going to switch back to my yellow. I know that I'm looking for Q, so I'm just going to go ahead and write the formula out horizontally like this. So mass was 100 grams, so I'm putting in the 100 grams for my mass. So that's 100 grams of water. The next one was the C, the specific heat of water we wrote right here, which was 4.18 grams per or joules rather, joules per gram times degrees Celsius. And then the last one we had was delta T, and we calculated our delta T to be 33 degrees Celsius. So now, once you have this, all you have to do is simply multiply everything together. So if I take the 100 times the 4.18 times the 33 degrees, I'm going to get a Q of equal to 13,794 joules. Because if you look, grams cancels out with grams, degrees Celsius cancels out with degrees Celsius, and the only thing I'm left with is joules, which is basically the unit here. So my answer is 13,794 joules.